Hey class, I just want to show you a quick summary of chapter 2, well just the first part of chapter 2, sections 2.1 through 2.3. Also note that there are other videos for some more like computational stuff that I'll post as well. As with chapter 1, there are a lot of key terms again. The new thing, one big difference is more computing, so there's 2 quick videos describing some of the computational tools you'll need, and I'll post a few others soon. As always, let me know if something seems difficult, confusing, unclear. Somebody already caught a little error in one of the homework problems, and I've fixed that and turned it into extra credit, so there you go. 2.1, categorical variables. Key terms, there they are. The one I would like to focus on are sample proportion and population proportion. Computationally, they are identical, but the way we use them is where the difference is. For example, we can say of all NU students, 62% are female, or we might, another statement would be, out of 200 randomly sampled students, 62% were female. Those are different. The number's the same, 62%, but the way we use them, the conclusions we can draw from those two different numbers are vastly different, and we'll parse that out and understand that more in the future. But for now, it's important enough to understand that, well, it's well enough to understand that those two things are different. Section 2, one quantitative variable, shape and center. So this is a lot of pictorial type things. It's a much more visual chapter. Do pay attention to the homework. That's really where I think a lot of the understanding will solidify. Okay. One thing is skew to the right means the tail's pointing to the right, skew to the left means the tail's pointing to the left. But many of these things should be pretty straightforward. As before, with sample proportion and population proportion, there's a difference between sample mean and population mean, but I won't get into that. Section 2.3, measures of spread. Again, a whole bunch of key terms. Many of them are computationally somewhat self-explanatory, but I did want to point out 2. The 95% rule, just a quick example of how it's used. First off, the restriction is the data must be approximately symmetric and bell-shaped in order to use the 95% rule. Just because you have a mean and standard deviation doesn't mean the 95% rule applies. The data must be approximately symmetric and bell-shaped. For example, if the CDC states the mean height of an adult male is 5'10" with a standard deviation of 5 inches, which is approximately what the CDC says, and then we can make a statement like 95% of all adult males are between 60 inches and 80 inches, or that means 5 feet and 6'8". There are, of course, men who we meet are much taller, much shorter, but 19 out of every 20 men adult males you encounter are between those two heights. Z-scores. Z-scores, as the book suggests and illustrates very nicely, you can use Z-scores to compare two incomparable things. For example, if math SAT scores have an average of 500 with a standard deviation of 100, and ACT scores have an average of 18 with a standard deviation of 6, then assuming that the data is symmetric and bell-shaped, which it is, we can compare somebody who took the SAT and with someone who took the ACT. So if Alice scored a 6 to 80 on the SAT and Bob scored a 27 on the ACT, those are two scores that live on entirely different scales, but because we know both are symmetric and bell-shaped and we know the mean and standard deviation, then we can compare them, like so. First, we compute the z-score of each. Alice's z-score turns out to be a 1.8. Bob's z-score turns out to be a 1.5. Because 1.8 is greater than 1.5, we see that Alice did better with respect to the corresponding distribution. Note that z-scores can be negative, that means you scored below average, but if they're positive, you scored above average. If they're negative, you scored below average. If it happens to be 0, then you scored exactly average. That's all I have for this part of chapter 2. I'll record another video with the rest of chapter 2 soon. Good luck.